Chapter 3, Section 3 through 5 are grouped together into this presentation because of their focus on using pre-written code in our program solutions. Two major goals of software development are that our solutions be robust and reliable. To pass the robust and reliable benchmark, the software needs to prove itself over time. In other words, it should not be easily broken. In order to attain these goals, we need to create and use well-tested, reusable software components. That is exactly what the class libraries provide. So let's dig in to sections 3 through 5. Here is a listing of Chapter 3 topics. Our focus is on the Java API class libraries, the random and math classes provided through the standard class libraries. A class library is a collection of classes that we can use when developing programs. These are pre-written classes with methods that are commonly used by programs. They are organized into packages of related classes. Instead of rewriting parts of programs, we can use reliable, well-tested components to help us build our software more quickly and with fewer errors. The Java API, which is an acronym for Application Programming Interface, is the standard class library that comes delivered with every Java development environment. This is similar to a browser's plugins. They work seamlessly together, so we can almost forget that the libraries are separate. Except for a few of them, we will need to include an import statement in order to use them in our programs. Because we so often use the string and system classes, these are stored in the java.lang package of the API, and they are automatically imported into our projects. We don't need to include an individual import statement for the java.lang package. The scanner class, however, is from the Java util package, and therefore we must explicitly import it into our program to use it. Here is an overview of the various class library packages that are part of the Application Programming Interface. This presentation will examine a few of them more closely, and you will be investigating 3 classes from the libraries: string, scanner, and formatting objects for Project 1, the class library project. Let's take a closer look at the import declarations. It is actually not necessary to use the import statement, but in order to use the pre-coded classes, then, we would have to use their full formal name each time we reference it in our program. This gets to be a bit cumbersome. Therefore, it is easier to use the import statement at the top of the file one time, and then we can just use the class name scanner throughout the program file. We also have the option of importing all of the classes in a package by using the wildcard *. I don't recommend this unless you are using several of the classes from the package. Why not? Well, because you will be wasting extra time and space by including classes that you don't need and won't use. Here are 2 examples of using import statements. One that specifically imports the random class, which provides us access to Java's pseudo-random number generator. We will see more examples of this shortly and discover that is very similar to C++'s random number generator. The second example shows the use of the wildcard operator. This is a common symbol within computing that means all. The AWT is the Abstract Windowing Toolkit, and it provides a standard set of graphics and GUI controls such as windows, frames, and buttons and text boxes for event-driven applications. We will investigate this more fully when we cover the topics from Chapter 6. This is a good example of when to use the wildcard, because when we do use the AWT, we do use many of its classes. The java.lang package, as mentioned earlier, is automatically imported, so we have direct access without qualifying the class names to the package. Since string is part of this package, it can be a little deceiving. String is not part of the Java language, but is a standard library class that we frequently use. The scanner class, being from the java.util package, must be imported. The random class is part of the Java util package also, so we will need to import it to use it. As you have seen and used previously in programming, this will supply us with a pseudo-random number generator. This allows us to add some interesting uncertainties into our programs and is a great tool for use with many game programs. You will find examples of this provided in the sample coin class and die class code. Since Java is purely object-oriented, we will need to instantiate a random class object and use its methods to generate our random-looking numbers. Unlike C++, we will not have to srand or seed the random number generator, as Java takes care of doing that in the random class constructor. Here are a few of the very useful methods provided. The first method is the default constructor that allows us to create or instantiate a random object. Inside the code of the constructor, it will automatically seed the random object. The next float method will return a floating point number between 0 and less than 1. The third method, nextInt, will return an integer between minus 2,147,483,648 and positive 2,147,483,647. Now, you may be wondering how I know those numbers. I read them out of the table. This is the full range of possible 4-byte ints in Java. The last method listed I find to be the most useful. It allows us to generate a specific range of values, like in C++ when we used the modulus operator with rand. It limits the range of numbers between 0 and 1 minus the number we provide. Let's look more closely at the example below that uses this method. Given declared int num and random generator, we see that invokes the new random constructor. We set num to generator.nextInt with an input of 20. This will give us the range of integers from 0 through 19. And if we add 10 to the result, it will shift that range of numbers to be 10 through 29. Here is the sample output from the random numbers example in your textbook. Let's take a look at the code line by line. The first line, again, we create a generator, which is an object instantiated from the random class. We declare int num1, and then we set num1 to the result of generator invoking the nextInt method. Then we print out that result. a random integer, colon, and what got stored in num1. When I ran the program, the result was 396,874. The next int that accepts an input parameter, as we see listed here, I use frequently. In this example, we will generate an integer between 0 and 9 and assign that to num1. When I ran the program, the random number generated was 3. Now you should practice with this program, and what you will find is you don't get the same answers that I'm showing on the screen. And that is because we're using the pseudo-random number generator. They should be different. Continuing, we set num1 to generator.nextInt with 10 as input and add 1 to it. Now, our results that originally would range from 0 through 9, if we add 1 to it, will range from 1 to 10. NextInt with an input of 15 will produce a random number between 0 and 14. When we add 20 to that, it puts us in the range of numbers 20 to 34. And the last num1 equals generator.nextInt with an input of 20 example, minus 10 will allow the range of numbers to go negative. So we have 0 through 19, subtract 10, gives us a range of values between minus 10 and positive 9. The last set of examples show the use of nextFloat. NextFloat returns a value between 0 and less than 1. In this example, num2 is set to nextFloat. When we run it, we see the result to randomly be 0.3687294. In the next example, we multiply the result times 6. That will give us a range of numbers between 0 and 5.9999999. The second line, num1, is assigned an integer cast of num2 plus 1. We are stripping away the fractional component by the number after we add 1. So my result when I ran this program was 4. And this is another way we could build an integer range of 1 to 6, but a rather complicated one. And not the way I do it, because we have nextInt with an available input of an integer, which is definitely the way to go. The next class we look at is the math class. This is part of the java.lang package. The math class contains many mathematical functions. It is similar to the math class that you use to include in your C++ programs. Some of the methods provided include absolute value, square root, exponentiation. The methods of the math class are called static methods. Static methods are invoked through the class name. No object of the math class is needed. We see an example here, setting value to math.cosine of 90 plus the result of math.square root of input delta. This may seem strange at first glance, but it actually makes perfect sense when we think about the math class. All of these methods act on primitive data, ints, floats, and the like. These are not objects. They are parameters passed to the method. There is no need for any object, so the math class methods are static, and we call them by using just the class name, followed by the dot operator and the method name. All of these return values that we then use in our program. We will examine static methods in more detail when we get into Chapter 5. Here are some of the methods of the math class. Notice they are all static and they all have a returning value, and they all have an input parameter required, except for a random method provided. That random acts very much like next float, except that it's a double. Let's take a look at the quadratic program from the textbook. I put the quadratic equation up on the slide to help us remember where this comes from, how we obtain the roots from the quadratic ax squared plus bx plus c, where a, b, and c are just numbers for the coefficient. So we have three ints, a, b, and c, that will correspond to the numbers. We have declared discriminant, root 1, and root 2 as double. We have a scanner object, and then we prompt the user to enter the coefficient of x squared. This will be our a value. We get that next int, then we prompt the user to enter the coefficient of the x component. That's our b value. Then we prompt the user for the constant c. We then use the quadratic formula to compute the roots for x. Assume it's a positive discriminant. The discriminant then, we set to that part of the equation where we raise b to the second power and then subtract 4 times a times c. Next, we determine root 1, which corresponds to minus b plus the square root of the discriminant divided by 2 times a. Then we determine root 2 by using the similar formula, but this time we have minus b minus the square root of the discriminant divided by 2 times a. Then we show root 1 and root 2 in the output. So given a value of 3, b value of 8, and c value of 4, root 1 will be 2/3, or 0.66667, and root 2 will be minus 2. All of these methods from the math class library are using the class name math, the dot operator, and then the method name to call the method. We don't create an object, we just use the class name to invoke the method. We will be using and creating our own reusable classes. This presentation focused on using ones that are already written. Soon, we will be writing reusable classes as well. We have seen a few of the rich collection of available components from the Java Standard Library. Project 1 asks you to learn more about these available components, focusing on the string class, the scanner methods, and how to format output with formatting objects. This will help you present numeric data in neat, readable ways. Happy coding!